So what's on YouTube? When helping my friend's teenage son understand subnet calculation, I saw how challenging these concepts can be for beginners. By breaking down the math and using simple examples, I created this guide to help others learn subnetting more easily. Oh, by the way, I borrowed example questions from Cisco Learning Network. Let's start with the basics. The /24 is a special notation called CIDR notation, and it tells us about the subnet mask. An IP address is 32 bits long, which are usually grouped into 4 sets of 8, called octets. /24 means the first 24 bits are for the network part. Each octet is converted separately. In this case, each of the first 3 octets becomes 255, and the last octet is 0. So the subnet mask in decimal format is 255, 255, 255, 0. So the answer is B. Now let's talk about the range of IP addresses within the subnet. The /25 tells us that the network is divided in a different way than /24. It means that the network part is now 25 bits long. This split the original network into 2 equal parts. I'm showing how to divide the network. If we put 0 here, we are telling the network devices we are using the first part of the subnet. If 1, the second subnet. Okay, let's convert one handlet into binary format. By using the subtraction method, we can easily determine the binary representation of one handlet. So, based on the calculation, the /25 bit should be set to 0. This means we have to calculate the combination using this part. Since the question asks for assignable addresses, we cannot use all zeros and all ones for this network. What would be the minimum assignable address for this network? If we set the first bit to 1, that would give us 192.168.1.1. The maximum assignable address is 192.168.1.126, since the broadcast address is not allowed in the exam. The closest answer offered is A, even though it includes the broadcast address. So, Class C networks, by default, use a /24 subnet mask. So 192.168.1 will remain the same for all subnets we create. We can focus on what comes after those 24 bits, which is the last octet. Moving from /24 to /28 means we are borrowing 4 bits from the host portion and using them for the network portion. By borrowing these bits, we are creating smaller networks or subnets within the original /24 network. These borrowed bits will determine how many subnets we can create. The first network address is 192.168.1.0, followed by 192.168.1.16, with subsequent addresses increasing by 16. Well, we could calculate each address manually. That would be time-consuming. Let's use a simpler mathematical approach. To calculate the number of subnets, we use the formula 2 to the power of the number of ballot bits. So we can create 16 subnets. The answer is C. We don't need to subtract all zeros and all ones in this case because these describe networks, not hosts. This question involves a /20 subnet. This notation affects the third octet. Let's look at how this works. With /20, the first 20 bits are fixed. The remaining 12 bits are for the host part. The broadcast address is when all the host bits are 1, so the third octet should be 15. The answer is B. So the last question, let's convert 248 to binary. This makes it /29 subnet. The host portion is 3 bits. The formula for the total number of IP addresses in the subnet is 2 to the power of the host bits. In this case, it's 8. However, remember we can't use the network address and the broadcast address, so the usable number of the host is 8 minus 2 equals 6. The answer is A. And that's it. We've covered some essential subnetting concepts. Try walking through more examples and you'll get the hang of it. Thanks for watching.